uh, area moment of inertia. Okay, I think I will record a video to clearly explain on the part that I have shown or shared with you just now. Okay, I'm really sorry on that. Okay, let's move on the mass moment of inertia. Okay, okay, sorry for that. Okay, share screen again. Okay, moving on to the example on the mass moment of inertia. Okay, we start with a very simple example first. Let's say you have a circle like that, and then you have a hole inside. So it's kind of a donut. Okay, then the radius for the outer circle here is 250 millimeter, and for the inner circle it is 125 mm. Okay, so you can say that first one you have a bigger circle which is 250 mm, and then you have another small circle, a hole actually, okay, this one with a radius of 125 mm. Okay, so if you look at this particular concept, if you want to determine the moment, a mass moment of inertia, okay, of this particular uh, object, okay, donut object. So this big, uh, we are going to determine the mass moment of inertia of uh, this object, the bigger one first. Then we subtract this small one, the small one, because this is the whole. It is a solid object. Okay, so then we will get this one. And this or object, we call it this lah. Okay, it's just like your CD, right? Or DVD, for that matter. This one. Okay, and the thickness is, let's say, 10 mm. Okay, quite thick this. Okay, and at the center here, we call it the G, your CG. It is at the center. It's going to be at the center because it is a round object. Then and then down here, we name it as point O. Okay, point O at the bottom here. So now, the plate is given to have density of 8,000 kg per meter cube. Okay, it is given like that, and the thickness is given 10 millimeter thickness. And here you need to determine its moment of inertia about an axis directed perpendicular to the pitch and passing through point O. Point O is here. Okay. Okay, first, we try to determine it is a solid disk. So, ID, okay? I of the mass moment of inertia of the disk, okay, at point O. So to do so, the general formula for this shape like that is going to be half m uh, r square plus m d square. Okay, so half. Okay, how about the m? Okay, let's say we determine this particular m first. M is equal to rho times the volume of the disk. Okay, this one, the whole thing, including the hole lah. So it is 8,000 times V is actually um, pi r square. Okay, this one is pi r square times the thickness. Okay, so it's going to be pi r is 250 mm is equal to 0.25 meter square, and the thickness is 0.01. Okay, because it is a 10 millimeter. Then you'll get m is equal to 15.71 kg. Okay, it is not actually your CD or DVD because it is too heavy. Okay, just the shape is like that. Okay, only the shapes like the CD or DVD. Okay, now we already determined the M, so M is 15.71 and the R is again 0.25 square plus M is 15.71 times D is equal to 0.25, okay, square, and everything here is equal to 1.473 kg meter square. Okay. Okay, we done on the solid disk. Now we want to subtract the whole. So I whole put the H lah. IH is equal to the same formula. So here is okay. M for this hole, since it is the dimension is smaller, so we need this one should be this. Okay, this is this, and it is MH. Okay, M for the hole. It is a arbitrary, and that is let's assume that the density is same. Okay, then pi here is different. Okay, it should be 0.125 square times 0.01, and here you got it as 3.93 kg. Okay, and here should be 3.93. R is 0.125 square plus 3.93 times Okay, now it is a bit interesting. It is not multiplied by the D. Okay? R is of course 0.1 to 5, but the D, as I mentioned earlier, the D is the distance from here to the center. Okay, just like this one. Should be 0.25. And then everything here will be 0.276 kg meter square. And the IO is going to be I this minus, because this one we subtract, okay? Because this one is just a whole, even though we calculate this part, but it is for the purpose to get rid of the whole. Okay? I whole with respect to the axis at point O, okay? And therefore it is 3 point, sorry, should be 1.473 minus 0.276. Then you will get 1.2 kg meter square. It is the moment of inertia of the plate above point O. Okay, moment of inertia at point above point O. Okay, this is one example. Okay, the second example is we only have two examples. I hope I can do it quickly on the second example. How to do this? Okay, the second example would be, let's say we have an object which, okay, object like this, which having a dimension of 1 meter, here also 1 meter, and from here, okay, to here, it's gonna be 2 meter, okay, from here to this point, okay, 2 meter, and then of course there will be a G, what we call it, the center of that, sorry, the CG of that whole object, okay, the centroid or the center of mass of this T shapes object here, okay, it is the centroid, and, which is, it is point O, which is at certain distance from point O. Okay, now put that point, and here is B, and at this point here is C. So if you want to look at this part here, you can say that it is a rod. You can say you have a rod OA, and then you have the rod which is rod BC. And these two rods is actually glued together or weld. Okay, is connected. But for the analysis, we want to look at it as two parts, not as a single parts. Okay. Now, um, we want to determine why. That's not really good. Okay, we need to determine first the mass moment of inertia at O. Okay, and then mass moment inertia at Z. Okay, first here and then here. Okay, at G. And this one we call it IO. This one we call it I. Okay, IG, not Instagram. IG. Okay, both of these two rod is weighing of 10 kg. Okay, rod OA is 10 kg, rod BC also 10 kg. Okay, now for rod back of textbook, we see general formula 100 and power of, sorry, power of, okay, and therefore I here at point O is going to be 112 ml square plus md square. 112 times 10 L is 2 plus times D. Okay. Why L is equal to 2 and D? Okay. And 2 is because the length of the rod OA. Rod OA here is 2 meter long. Okay. If you look, okay, let's say it is rod OA. The length is 2 meter. And this particular have its own centron, its own center of mass, okay, at the center. And it is, with respect to point O, it is 1 meter. Okay, that's why here D is equal to 1. And if you solve this one, you get 13.3 meters. Let me draw DC at point O is going to be 1 square plus md square 12. Okay, I think tonight or tomorrow morning I will give you another quiz on this part. Okay, so here is the same. The weight is 10 kg. Length is again the same length, which is 2 meter length. Square, don't forget the square. I normally miss this one. Okay, D is again Okay, if this is your rod BC and centroid is here, okay, and center. So point O is somewhere up there, okay, and the distance from the center here to this one is 2 meter, right? The center for rod BC is here, okay, at the center here. So it is 2 meter from point O. So here should be 2. And if you resolve that one, you get 43.3 kg meter squared. And IO is going to be IOA respect to O plus IBC point O. Okay, on previous example, we put here is minus, okay, because of you have a hole inside this particular disk. But now I put it plus because of we analyze this object and it is attached together. Okay, so that's the difference. So here you have rod OA and then you have rod BC and it is uh, a physical object, two physical objects. Okay, just now this one is one big circle and then you minus the inside because this one is whole. It's nothing there. So that's why it is a minus. And here it is plus. Okay, that's this, the rate. And if you do this, it's going to be 13.33 plus 43.33 at 56.66 kg square. Okay, that is the mass moment of inertia at point O. Okay, but uh, this is the mass moment of inertia at point O. It is solution for part A. Part B. Okay, for part B, it's going to be first we need to determine this y bar. What is y bar? Y bar is summation of the distance, individual distance, okay, of each of these uh, object, the centroid of this object. You can put in D or whatever you want. Put it, okay. But in the books, I think we just follow what appear in the books. We put it the Y like that. Okay. So it is almost similar like the Y bar, but it is for the individual component of this object times the weight. Sorry, the mass of the system, summation of mass. So here on the top part, what we have is, okay, what is the y bar, I call it same y bar, for this particular rod here, okay. If you recall, it is like that, OA, and science rod is there, and the, what do you call it, its own distance here is 1 meter, and it is 1 meter there, and the weight is 10 kg. Okay, since it is a summation, okay, it is for uh, this the rod OA. Okay, this one for rod OA, and then we plus with, because it's summation. Summation you have to plus another one with the rod BC, which is rod BC. Uh, the distance is 2 meter from here, so it is 2 times the weight is again 10 kg, and this one for the rod BC divided by uh, 10 plus 10, because this one for rod OA, it is for rod BC. Okay, the mass, summation mass. So you have mass for the rod OA and then for the rod BC. And here, what you get is 1.5 meter. So your Y bar here is 1.5 meter. It is the location of this point G. Okay. Now you can go back to the definition of any body, any shapes or body like that. Okay, plus m d square, and I0 we already determined before that the value is 56.67 plus Ig plus m is, okay, this one, when we, for this part here down here, it is for the whole object. You want to resolve for the whole object, because G here is the center of mass for the whole thing, the whole T shapes. We are not going to resolve or solve as a individual parts. Okay, and therefore for the M it's going to be total mass. Okay, OA plus BC times D. Okay, now as I mentioned earlier, D is the distance between the center of mass to the uh, reference point, which is here we want to determine the I0, so sorry, IO. So with respect to point O, and therefore it is our value 1.5. Okay, D here is our Y bar. Okay, square, don't forget. And therefore Ig, if you solve it, it's going to be equal to 11.67 kg meter square. Okay, that is the value of Ig. I think I will also upload another video on how to actually derive this one, the derivation. Okay. Do you think that is really important for you to understand how do you get this derivation? Okay, I will upload a video, separate video on this one. Okay. I'm really sorry earlier that I have shared with you the area moment of inertia, not the mass moment of inertia. I made a mistake. Okay? I didn't put specific note on my notes. Okay, and actually that is for today. Any question? Any question?